All right. So let me go ahead and share my screen. My screen. You are able to see my screen, right?
Yep.
Awesome. So okay, let's get started. Good morning, good afternoon, good evening from wherever you are joining from, and welcome to the Data-Driven Community Virtual Meeting. A few words about the Data-Driven Community. If you will check the community website, there you can notice we are managing two different branches of activities. Scroll down the page a little bit to see the upcoming events. On the left side of the page, you can notice Future Data Driven Summit, which we are coming up in the September. So, an annual joint conference we are leading and running with multiple data platform user groups as our partners. The second branch of activity are the weekly meetings of the Cloud Data Driven User Group, just like you are seeing today. And you are more than welcome to contact any of the community board members. Jean Joseph is the founder and the co-administrator, and Ronan is the second co-admin, and Anna Wikes is the third moderator. My name is Deepthi Goguri, and I'm a database administrator and also a Microsoft Data Platform MVP. I'm thrilled to be co-admin of the DBA data-driven community. I need more coffee today. And I will be hosting today's session. Um, and together we are here to help and serve the data platform community. And during the meeting today, please feel free to use any chat for any questions and discussions as well. And do not hesitate to reach out. Like if you have any questions, put it in the chat window. And if you want to use any reactions, it doesn't interfere with the course of the meeting. So if you hear something you like, love, either put it in the chat window or use these nice little reactions over here. And next week, right, back to back to this week and next week, we are only talking specifically about the security in Azure. So in the next week, I'm going to present on the defend the core multi-layered security for Azure SQL in action. So this will be a very good second session after current session. So please go ahead and register now, because these two sessions back to back, if you listen to them, I'm pretty much sure you'll get so much knowledge about Azure security concepts. So do not hesitate and just go ahead and register for my session. Shameless plug-in here from me. And today I am so honored to moderate this session, and we are so honored to have Karen Lopez with us. She's a data evangelist for Info Advisors and also space enthusiast. I love to hear more on that. And team data coach as well. Karen is senior project manager and architect, and she have more than 20 years of public speaking experience, including keynote speeches and demonstrations. So, wow, that's 20 plus years. You have so much knowledge. And Karen, it's really honor to be here today, and I'm so honored to um, you know um, host this session for you. And Karen, if you can go ahead and share your screen and talk a little bit
Great.
about your space thingy.
Yeah. Let me find it. It'll just take a second. So I'm also honored, and I don't know if everyone knows this, because I was going to use this as an intro, that I'm using a lot of the same slides that I used at Fabricon, where you and I both spoke, right, about these security things. So it's kind of
Yeah.
it's kind of interesting that we're doing it back to back again. This makes me really
Yeah.
excited. So I do encourage people to go sign up for the next one as well, because she's going to talk about similar things, but also the things around what I'm talking about as well. So anyway, so I just wanted to say that normally I'm based in Toronto, but today I'm in Kansas City because I'm doing a course here in Kansas City for the Kansas City DAMA chapter on AI and data management and AI security. So this is a really great, I'm glad I'm doing this topic as well, because I've been talking about security all this time. So that's where we are. So a little bit about me. This is about it. My bio says more than 20 years. It's a lot more than 20 years, but I decided to stop it at 20 because people think I'm really old otherwise. So I'm also an MVP and an MCT. So the things we're going to talk about today are some introductions to it. And I want to say the scope of this presentation is security features inside SQL Server and Azure SQL DB. So there are all kinds of other security things like authorization and access rules and firewalls. That's not part of my presentation. I'm going to talk about features inside SQL Server and Azure SQL DB that can help protect data as well. So that's, and some services that we can use. My basic mantra for all my presentations and how I work is every design decision comes down to cost, benefit, and risk. So one of the things I do as a project manager and a data architect, a data engineer, is there are very natural debates that I have as a data person with DBAs and developers. So because DBAs and developers are paid and evaluated, rewarded, and punished for how soon they can get code into production. And DBAs are generally measured, encouraged, rewarded, and punished based on performance. And these things can be a difficult issue with the trade-offs here with security. So it used to be ages ago that I would lose the discussion of encrypting data, like encrypting a column or a row in a database, because that impacted performance, and DBAs would not allow it. One of the reasons it impacts performance when you're doing it in a column is you have to use a very large data type to store a full encryption in there. It also takes GPU or CPU time to encrypt and decrypt the data. But we fast forward to 2025, where there's all kinds of legislation and compliance issues that require us to encrypt data. And there are many ways to do that. But lately the trend, so I see that Sharon is saying she can't see the slides. I'm assuming some of you can see the slides. Oh, and someone else says they can't see them. So should we fix that for a second? Ronan, are you saying you can see this? Okay, other people are saying, okay. So I'll relay the advice that a lot of people give is you could try logging out of Teams and coming back in. Sometimes that fixes the problem, but I am sharing the slides. Okay, so fast forward to 2025, and we find that now with all the legislation and everything, that it's important now that we might trade off some performance aspects or have to pay more, that's cost, pay more for better performing hardware so that we absolutely must encrypt the data. So that's just showing how over time our best practices have changed related to data security. And why do I want to talk about this? So I normally talk about things like data quality and database design and how to do things in Fabric and do data engineering. But security, privacy, and compliance are something I'm really passionate about because I love data. I'm the data chick on social media. I want everyone to love data. And one of the ways we show love for things is making sure it's secure and safe. So I'm going to ask you to put in chat if you want to, who you are. Like, do you not what your title is, not what your current job is, but what's in your heart of hearts? What did your mama raise you to be? Are you a DBA? Are you a data engineer, project manager, developer, data enthusiast, and everything? So if you want to put those things in chat, that gives me and everyone else sort of a better understanding of who we're talking to. So the other thing that if we were, see, I'm seeing a lot of DBAs. I might say bad things about DBAs here, but only because in the past, DBAs fought me. Oh, look at that, data architect, data modeler, yay. Excellent. Is that in the past, like I said, DBAs are paid for performance mostly, not always, but most of their on-call calls are about systems being down or performing too slowly or timing out. So this is a natural debate. It's a conflict that is put onto us by what our focuses are. Look at all those data architects, great. So lately, we hear a lot about data breaches that are related to ransomware, but I'm also curious for you guys to think about what sort of harms or breach or data issues that have been in the news that aren't about actual like malicious people attacking data. So maybe in the Q&A time, we can also talk about that. So one of the reasons I also talk about over time. So for years, um, OWASP, which publishes this survey of security related things, for years and years and years, the number one data breach cause was SQL injection. And one of the reasons that makes me not so happy is for decades, we know how to test for SQL injection. We have tools to stop us from writing, and this is a coding thing. It's not a database thing. SQL injection works because an application, a web app, something isn't protecting inputs that could contain SQL commands. And therefore, that SQL injection, that had been the number one cause forever. And it used to really upset me again, because we have training on how to protect the parameters that they use as input. We have tools to measure for it. We have tools that will stop you from doing it that way. We have consultants that will review their code, and yet forever it stayed the number one. But I had predicted, because of the way the news was going, is this concept of open buckets. So the way it usually made the news was that an S3 blob storage left unprotected with production data in it or sensitive data, people found it and took the data. And that was literally like printing out all your data and passing it around to all the mailboxes in your neighborhood. That's the equivalent of it. So that's not a technology issue. This is 100% a human issue of SQL injection being allowed and not realizing that if your application's running with the rights to write to data, when you have SQL injection, that means that outsiders just using the web or just using a service to query your data can actually change the data or take the data or find out or delete the data even. But because we kept hearing more and more about data being breached, not because it was hacked, but because people were putting data out on the interwebs without protection to it. And it was always done the way most security breaches or security design problems have, is that we trying to do something fast and solve a problem. So most that I read about that were of database breaches was someone taking a backup of the database. It's too large to email. They can't put it to SharePoint or another internal file thing because they need to share it with, say, a developer who's an external consultant, or the vendor who needs to look at the data to see why the software isn't working, one of those things. And so people would put it out into an Azure storage blob or Dropbox or an Amazon S3. And it used to be, for all those storage services, they defaulted to public access. So you'd create a file for a container for it, you'd stick it in there, you'd send the link to the people, not realizing that it's totally unprotected. It's out there. It's as if you posted it to your LinkedIn account as a file to share. And the cloud providers finally realized a couple of years ago that the way you fix this is you make all these storage accounts and these containers to default to no one can see it. So kind of the zero trust approach. And then someone has to intentionally go in and grant the public access to it. This one change on it, it wasn't the cloud provider's fault or the service provider's fault. This one change helped humans protect themselves from just being idiots. And I'm including myself in that. So that has changed. And the broken access control, which includes these putting things out in public, is now the number one way that data gets leaked. And you can see that SQL injection has gone on down to number 3. Cryptography failures isn't that the encryption failed, but usually because people publish the key for their encryption to GitHub or to a SharePoint site or to a website when they shared some configuration or a connection string. My other favorite was there are a lot of services out there that if you type in what database you use and the name of your database and what account you want, it will generate a connection string for you so that you don't have to go figure out the syntax. Well, of course, you're sending a random website the login information and the name of the resources. That's a security risk, even if the website never intended to do that, even if the website says we don't store any of this data. So we've all heard of ROI, and that usually comes at, that's kind of a way, return on investment is kind of way, every design decision comes down to cost, benefit, and risk. But in 2025, it also stands for risk of incarceration. And the reason I say that is most compliance and privacy legislations and policies these days actually allow for criminal penalties to be charged against organizations and the leaders for data breaches where there are egregious errors in how the data was handled. So for instance, if you're dealing with highly sensitive data and your company hasn't put in data exfiltration filtering, if you don't do monitoring, if passwords are just shared in a SharePoint, a spreadsheet on SharePoint, or literally someone I worked at a project a while ago was contacted by someone in China via LinkedIn who wanted a list of all the customers that we had based in China. And she didn't think that was an odd thing. So she gathered all that data from our customer database and sent it to the person via LinkedIn. And I'm here to tell you that that's an egregious breach. And it really fell down to, yes, that person didn't understand why that was a risk. She had no idea that sharing data was illegal, violated privacy laws, and made it very unsecure. Her take on this was they just wanted a list of names, and you can't do anything with a list of names. And we as data people know you absolutely can do things with a list of names. So it comes down to training, but we should have had tools in place that would have alerted somebody or forbidden her from downloading that data outside the system. Her actual job didn't have any reason she should be able to export in bulk data from the system. So in that case, in theory, that could have resulted not just in penalties, but criminal charges for that. So we're going to talk about the first feature in SQL Server, always encrypted, because always is a good thing. Now, always encrypted just doesn't mean it's an encryption thing. It's actually a feature of how your data goes into and out of your database. And it requires, the one blocker for this for people is it requires a certain version of .NET to be used on the client side. So an application or Excel does this, or Tableau or Click or Power BI. As long as they can use this .NET library to pass the queries back and forth, you can implement this feature. So if I had time, I'd be doing a demo where I show how the data is encrypted, because I take Excel and point it to a columns, some that are encrypted regularly, some that are encrypted manually, and some that are encrypted via always encrypted. And what this does is it has a column, it has two keys, like most encryption things, has a column master key that's stored outside the database, and a column encryption key that's stored on the SQL Server, that you need both of them to see the decrypted data. So you can see in the example, we have social security number. It's going to be encrypted. It's going to be a lot longer than that, but it's encrypted. And the difference between this and regular column encryption is it encrypts it all the way through, not just in SQL Server. So normally, like if you manually encrypt things or use an encryption scheme on a column of regular encryption, as soon your query returns the data unencrypted. It's only encrypted at rest, but not in flight and not in use. With always encrypted, it stays encrypted all the way through, goes through that .NET library, which brings the two keys together, and then produces the decrypted data into your thing. So I see the question, can Power BI decrypt? What I will say is Power BI, because it uses the same sort of technology to connect to SQL servers or Azure SQL DB, it should be able, as long as the client side, so wherever the client's running, has that decryption key, has the encryption key, then it will work that way. And I know for sure, like it works with Excel. So as long as I have the keys, you have to have the keys. It's not any Excel, it's not any Power BI. You have to share these keys. And along with any key management strategy, as people come and go from your organization, you have to rotate the keys as well, which is a cost, meaning time and coordination, but it's totally worth it because you should be doing that for all your encryption keys. And you might have to rotate them because they've been compromised because someone accidentally put it in GitHub or put it on the SharePoint file or something like that. So the other key feature here for always encrypted that other encryption schemes don't have is that it encrypts the parameters you're sending to the database. And most people don't think to protect this, but someone, an application or a person saying, show me all the customers over the age of 65 who live in California, who have a social security number that starts with 3, like I'm just making these all up. Those parameters are being sent to SQL Server. Well, sometimes if you put someone's name or their account number or their phone number in there, that's sensitive data that needs to be protected. So the .NET library on the client side encrypts those parameters. They get sent to SQL Server and they're protected along the way. And the whole reason for always encrypted is to deal with the man-in-the-middle attack. So many breaches we've had in the news were based on data being intercepted from a data store and then to someplace else. So one of the most famous ones was the large Target data breach, where the data was encrypted as it was collected, but decrypted through the payment processing system so that it could then use that data, like your credit card track data, to do the charge. And then it was, used to do that. Well, someone who got access through a third-party contractor was able to grab that data between the swiping of the card and the sending it to the payment processor. That's a man-in-the-middle attack, and that's the problem with most encryption schemes is they get decrypted, they're sent to something, but they have to be decrypted so that the other thing can encrypt it using their own or just use the plain data. So there's 2 options for always encrypted. There's standard. This is what I use in most of my demos and things like that. But there's also AE with secure enclaves, and I'll have a slide about that. So this is an example. So one of the things is, because setting this up requires not just making changes in SQL Server, but setting up your keys and designing the type of encryption, you typically use in SQL Server Management Studio a wizard that's built into SQL Server Management Studio. You can also do this via PowerShell or any of your other automation or coding things. But you can see in this particular database, there's a national ID number. You choose what the encryption type is, which is determinate or random. And those lead to the difference between the two is random means the same value gets encrypted to a different value. So if my customer name, last name is encrypted as Lopez, if I use random encryption, 2 people with the name Lopez will have different values. That's great. That's super, super secure. But there are also blockers to doing that because some of the features that you use in SQL Server itself sees the encryption value. Your application sees the encrypted value. So it can't do joins on random things because the owning key and the foreign key will have different values, but almost always will have different values. Deterministic means I'm using the same sort of encryption. So all the Lopez's, all the values will have the same encryption value because it's deterministic. So you do all this and then you run all this. Now notice this note. While you're setting this up, you can't be updating the data until it gets all the way through. So that could take time. The feature is it's a column level thing. So there's other ways. There's TDE for encrypting your files and your logs on the hard drive. But this is encryption at the column level. So think of it at the fact level, which makes sense. It protects that data at rest and in memory and in flight, and it uses the 2 keys. So foreign keys must have the same encryption type. And if they're random, you have to be able to insert the randomized data and not insert them separately, because then you'll get two different values. Your code or your client needs to support .NET 4 or above. And then there's the secure enclaves thing. So secure enclaves is what I recommend that everyone do, because this is real protection. It's a special security-based enclave. There's a way of attesting the security to it. You have special ways of handling the keys, and it only supports random. And that will be a constraint through cost, benefit, and risk to what you can do with the data if it's randomized only. So the good news is it's in-place encryption. It's not data being sent there. It's not data being sent there and then encrypted and returned to the database. It happens as soon as the data is written to the database. It also means that there are confidential queries and the indexing will work. Why would a database designer love it? Because it's always encrypted. I don't have these places where my data is exposed. It allows people who are experts in the data to determine whether it should be encrypted and how it should be encrypted based on all those trade-offs. I love this because, like, for instance, I worked on a travel system, and as the data person there, the data owner who set the standards for it, I knew that things that most people wouldn't think are sensitive data needed to be encrypted. So I was typically performing the role as a data steward here, but I knew that something as simple as a special meal request on a flight or a train could be sensitive data because some people have medical conditions that require, gluten-free or no nuts or something like that, or because they have dietary preferences that might be tied to their belief system, and therefore that's sensitive data that we aren't allowed to share. It's not secret, it's just we aren't allowed to share it. So I would know the column that stores the special meal request needs to be protected just as much as a social security number does. My developers and DBAs, they kind of understood that, but they're not experts in the data. They're experts in the technology and the performance of databases. There are some database designers who are experts in the data, but I find we make a great pair. We complement each other. People who live and die by the meaning and the quality of data, and people who can make it actually work. I love that the parameter is always encrypted, and I love that it's built into the engine. So theoretically, if your application already uses this .NET library 4 or above, in theory, you could start using always encrypted and not change a single line of code. Now, as we know, that's in theory, but it's very tiny changes. You're not writing code to do the encryption and decryption. The engine and the library are doing all of it. Next one is dynamic data masking. Microsoft calls this a security feature. I consider it more of a privacy one. This is just me nitpicking on it, and I'll explain that why. So dynamic data masking, it's just like it sounds like. So let's say I have a table with a credit card number in it. I want to store the full credit card number, but I don't want everyone to be able to see it. So I want to mask it for certain groups of people. And we all know, if you're a data expert, that the legal and the compliant way to mask a credit card number is by obscuring all the numbers and then showing the last four. Now that's required by PCI compliance. It's the best way to do it, because if you're an expert in credit card numbers, you know the first digit means something specific. You know the first four digits mean not only is it a Visa, but it's a TD Aeroplan business Visa. The first four characters tell you what the product is. The other numbers don't have meanings, but they have checksums. The last four are pretty much meaningless. And the reason I know this is I once had two credit cards with the same last four numbers, which was really annoying. But, it can happen. So this is a way of masking the data at the database level. So here's some examples. And the first one, 16 characters, all but the last four masked. I'm going to guess that's a credit card number. Here is a K with some X's, an @ sign, an I, X's, and .com. That's probably an email address. $99999 is some sensitive value. I'll just say it's probably a salary. June 99, 99999, which is not a valid date in SQL Server, but I'm using it as an example. That's probably something sensitive, not like today's date, but someone's date of birth or date of death or date they became a customer, something like that. And then KXXX Lopez is probably my name, but it could also be my twin brother's name. His name is Ken. And so the X's don't vary based on the length of the name. They're just sitting in lieu of the actual values. So the way you do this is something it's just a property of a column in your database. So there's no wizard you have to do. So this is an example. This example is actually part of Microsoft Learn. So you can go to the dynamic data masking. I think it's a tutorial or getting started thing. Actually run all these commands locally just to play with it. So I have a table called membership. It has an ID, first name, last name, phone, email, and discount code. So member ID, you can see it has typical stuff, but it's not masked. First name is masked and it has a function. So these masks are the syntax for it is to call it a function. And you can see it says partial, and then it has 3 parameters to partial, 1, xxxx, 1. So what this means is I'm going to show the first character. I'm going to put X's for all the other characters. And then it's going to show up like KXXXX. For last name, I'm going to go ahead and show all of it. It's not masked. For phone number, I do want to mask that. And then I set it to default. And we're going to see on the next slide, default means you, SQL Server, have a default way of masking this particular data type, varchar. And so it's going to do it that way. And email has a function called email, and it's going to mask it the default way that SQL Server knows how to do it. You don't have to use these defaults. They're just shortcuts for good ways of doing this. So generally you have to decide whether the default is good enough or not good enough. And then there's a discount code, and it's masked with something called random, which only applies to numerical data types. And this says random. I'm going to randomly replace this discount code with a value between from 1 to 100. So that's a way of doing that. So these are just examples of some of the functions and defaults. Let me just see. Yeah, okay, I'll come back to this. So thing I like about it, it's column level. It's not at the row. It's not at the table. In the old days, if we had sensitive data in a table, we had to encrypt the whole table, which was, affected performance. It affected people's ability to use the data in the table. It was all or nothing. We did it because we had legal requirements to encrypt the data that way, but this is so much better. Sorry. It's meant to complement other security things. Sorry, just a second. And so the reason I say it's not a security thing is when I said SQL Server does this or this, what I mean is it's not masked at storage. It's masked at the very last minute. So you send it your query, it goes and reads the unmasked data, and then it returns, if you don't have permissions to see unmasked data, it returns the data with the mask. So it's the last thing it does to the data before it returns it. And that means it doesn't impact performance that much because your query optimizer and everything is just chugging along, has no idea that this data is going to be shown masked. It's only at the last second that it gets turned into mask. So from a cost benefit and risk point of view, it's very little. So there are 5 default functions available. There's default. So default is mask it the way you want to mask this data type. So numbers, characters, email addresses, that kind of stuff. So email's one. There's a custom string that you can do. That's the partial whatever. There's random for numbers. And then, so I can't really see your whole comment, Ronan, sorry. And then the newest one that got added was date time. So a way to mask date time. So one of my issues that I have with data masking is in some legal jurisdictions, you're not allowed to use, one of the reasons people mask is to use this data for dev test without breaching too much privacy. But the issue with it is in most jurisdictions outside the US, it's illegal to use real data this way. One, because you never got consent from someone to use their data as test data. And two, if you mask data good enough that no one can figure out your name, your address, your date of birth, your salary, or whatever, then it's not really usable as test data because you can't see the actual data. You don't know if the math was right because you can't see the dates of birth. So this is what I have a problem with. So here's the defaults. So the default for strings is to replace everything with X's, for numbers to set it to 0, for date times to set it to this, and for a binary data type to set it to 0 or off. For emails, it's always the first character of the username, and then everything else is X's, then X's for the domain name, and then it's always changed to .com. So my email address here could be Karen@datamodel.org, but this is how it would get masked. Custom is that partial. So you tell it the first and last values to show, and X is in the middle, for example. The default for random is just for numerics with a range like 1 to 100. And for the date time, it sets it to a specific date. These defaults may or may not be good enough for your needs, but it's good to know their defaults. I will say that in Azure, in the portal, it's not an actual feature, it's just a portal feature. It also allows you to choose credit card as a masking type, but it's just the portal doing that work behind the scenes to change it to a partial mask. So the one trade-off is the data in the database is not changed at all. This is just masking at the end of a query. But the big trade-off is, and the other reason I think it's not a security thing, is ad hoc queries or user queries. Like if you can point Power BI or Tableau or Quick to it, or Excel, or you have access to run queries on your own, you can expose the data. So because the data isn't masked in the database, I could literally say, show me all the employees that have a salary over $6 million. And SQL Server will return you all the rows where the salary is over $6 million. The data will be masked, but you're able to determine this because you could literally put ranges in there and figure out people's salaries. And you could use show me all the customers whose first name is Dave, and it would literally bring you back all the Daves, but you just see the first name mask. So it's not really a security feature. I consider this a way of people need access to understand which it is. So the example I use is in airports, the upgrade or standby list often shows the first 3 digits of your last name and then your first initials. So you can kind of see who you are and where you are, or someone with a similar name. Like my brother and I would have the same values, Ken and Karen Lopez. But it's a way of not sharing that with everyone. And we joke, for those of us that travel together, that we know where everyone is on the upgrade list because we can figure out what their names are there. So it's not a security thing, even if Microsoft calls it that. So here's a blocker. You can't mask an encrypted column. So the two things we'd want to use together, you can't use together. You can't use it on a computed column, but if you mask the underlying columns that go into a computed column, it will use the masked data in the computed column, which may or may not work for you. So the mask is returned. If it also protects the data, if you do a select into or insert into, it's still masked. So also newish to this is that specific columns, you can grant now unmasked permissions to people so that, okay, it used to be you had to grant permission to the whole database for someone to see unmasked data, but now it's more granular. I can say, Karen, you can see the social security numbers, but you can't see the salaries. So I can set it up that way. I can set unmasked for a whole table or for a whole database or for a whole schema, whatever works for you. Now, the one thing I'm going to point out is people who have system administrator access can always see unmasked data. So that can be a problem. If that's another reason why I don't consider it a security thing. But what I like about it is this frees up developers and DBAs and other people having to be experts in the data so that I know that credit card numbers by compliance have to be masked all but the last 4 characters, not every other character, not adding 9 to every number. Like there's a standard way. And I, as a data expert, data steward, can specify this is the mask for this data. And so it's more reliable. And the other problem I've had, when every developer was allowed to design their own mask, then people could query the data using different systems that use different masks, and then they could figure out the unmasked data. The other thing I like about it is I've often seen masking data being pushed into the backlog, the parking lot, or into version 2. Now I can just do it once in the database, and that's it. The next one is row level security. It's just like it sounds. So in the olden days, to keep a doctor from seeing all the patients in the hospital, we had to either create a view that restricted them only to the rows they were allowed to see. We had to do some really granular permissions. We had to put it in the application code. That was hard to do, and it left big gaping holes because we didn't think about the edge cases. Now it's a feature right in our database. We can grant access to a row in the database based on a security policy. And that's why I like it. And the other reason, just like masking, this works no matter what client you're using. So one of the things I've learned over the last 30 some years is if we leave all the security to the application to apply, now when we want to roll out all these self-serve BI or let people do queries or add a new system, we have to try to redevelop all that logic. And I'm telling you, we don't have time for that. So this is why you want the database to do it. So it uses this predicate. I have an example of it to filter the sets. It's applied when reading the data. It can also be used to block write access. So you can say, hey, you might be able to see this row, but you can't update it. That's a very common scenario. And also, if you can't read it, typically you don't want people to write it. And so it can block that as well. And it uses inline table functions to do this. So one of the other features, unlike how we used to do it, is if I say, show me all the people in Canada, show me all the customers in Canada, but I don't have rights to see customers in Canada, it will just say, we don't have any customer. Like it'll say, there are no results, 0 results. It doesn't say, hey, you don't have a right to see this data, contact the administrator. It doesn't say, there were 13 rows, but I can't show it to you. It literally pretends from your point of view, the data doesn't exist. So if all the rows are filtered out, you get a null or 0 results. For block predicates, an error is returned, and then you get to decide what to do with that error. And the other thing about this, it works even if you're DBO or database owner. So this is a way for protecting yourself against admins doing things. So here's an example of how it works. I create a schema called security. I create a function, and I say whether the where there's a sales rep equals the username I put in there, or the username equals manager. Like this doesn't make a lot of logical sense, but that's how Learn does this example. And then you create this policy called sales filter that provides the predicate of sales reps to see orders and where the state equals on or Ontario. I don't know which it is. So here's what would happen if I run this as sales rep 1, and then I'm going to get a different set of results. So the way you test this, and I use Management Studio, is I'm going to pretend like I'm sales rep 1. I'm going to select all from sales order, and I'll get probably just the orders that I'm allowed to see. If I'm sales rep 2, I do a select star, I'll get just the sales orders I'm allowed to see. But in my case, in this example, if I'm a manager and I say select all from sales orders, I'm going to see all the orders because I've granted that, or I haven't filtered out what a manager could see. So this is where it's user-based, but you write the predicate. It's not the same as, but think of it as a where statement that gets reused every time. So this way we don't have to build a view, we don't have to write it into the application. So why do I love it? It allows us to do this in a data-driven way. And what I mean by, in the past, we used to put this in the code or build a view. And then if we had to change something, we had to go update code and redeploy code and test code. Now we can just change a data value somewhere or grant something based on a data value, and there's no changes to code. So another big thing is to protect data is we can't manage or protect data that we don't understand or don't know where it is. So there's a feature in SQL Server and Azure Portal for SQL databases that is under tasks, data discovery and classification. And I'm going to guess most people who use Management Studio every day have never used this and might not know about it. I'm basing that on the times I've done a full presentation on this, that people don't know this has been around for quite a long time. And so it allows you to classify data. Now, the way this works is it's looking at your table and column names and using a regex-like formula to determine what type of data it is and what sensitivity label it should hold. So you can see that, and it's guessing based on, like I said, it's not AI, it's just comparing patterns in the data to see if it's a name, if it's credentials, if it might be a date of birth, if it might be a national ID or contact information. It's guessing at it. And then you can then set a sensitivity label to say, this is like, I don't like these examples that come with it. Confidential GDPR is not very useful. And the one thing I want to point out is in this particular data classification, you only get one label per column. So for instance, if something is covered by GDPR and CCPA, the California privacy thing, you still only get one label. So it ends up you have a lot more labels than what you actually need. But it does what I consider the 80-20 rule. It will allow you have to verify these. And then if you change it, you accept it, then you save it, you apply it, and then it stores these information types and sensitivity levels right in the database. So it makes these recommendations. I can dismiss it, I can save them to the database, I can change them. You can see in this example, I decided that account in the test table, first name and last name, doesn't have, it's not sensitive data, because in my case, I know this is test data, so I don't have to protect it. Error log username, in this case, I chose not to protect it, but everything else I did. So then you get this nice donut graph thing that will tell you what percentage of your data, what distribution of labels and the information type, how many columns have been classified, how many tables have classified data, and how many unique data types you are. And then you can see all the classifications. Now, you can do the same thing in the Azure portal, and it runs very much the same way. And then it also gives you a prettier donut chart for doing this. So you can also customize your information types and sensitivity labels, writing your own thing. The one thing I want to say, I can't remember I have slides, so I'm going to mention it here. This is slowly being replaced by, and this is an either or. We should probably be using the Azure or the Microsoft Purview versions of data classification, because it doesn't just use column names. It actually looks at your data and determines, these 16 digits that start with 2, 3, 4, 5, and 6, and, is probably a credit card number. So it's actually looking at the data, not what we named it. This makes it better. And then it does the same thing. It classifies it, makes a recommendation, and you can change that or not. So I'm a better fan of that. But if you don't have Purview, this is a great tool to do, because I'm going to tell you, a consultant coming in and evaluating, or someone who wants your job, will run this for you and then go to management and say, hey, we have all this sensitive data and it's not classified or labeled. So you want to run it so that no one else does. So, so So ledger tables and databases. I love talking about this. And the thing is, I make this snarky comment, you know, blockchain would have to show up in a security presentation. So this is a feature. Oh, now I'm hearing myself. Can people hear my voice? The recording or something? I think that's because someone needs to go on mute. Anyway, I'll keep talking as long as people can hear you. Yeah, I think someone needs to go on mute. So yeah, so that's why we use a table. Okay, I found it, turn it off. So we have ledger tables and ledger databases, and it has these components, a digest, which I'll talk about. You can have a ledger table to say that's updatable or append only, and you can store the digest and the record of the transactional in immutable storage. Immutable storage, confidential computing, is storage that uses a combination of hardware and software and operating systems to make sure that data cannot be changed in any way. And you also use the regular access controls, but it's much harder to tamper with the data. And then you can ask the ledger system, can you verify to me that this data hasn't been changed in a way we don't know about it? So update ledger tables, it's made of the updatable ledger table, then a history table, because it's not really updating the table, it's logging the changes. It's using change data capture the same way. It's using temporal tables the same way it works. So it's using this. And temporal tables are a feature in SQL Server where you can not only query the data, but you can query the data based on a time frame. And so that's what the history table is doing. And then there's a view that ties this together to help you do this. The history table and the ledger are, are created by the system when you create a ledger table. So you don't create them, you don't maintain them. So here's an example. I like to use space examples. So I have this table that I created based on NASA open data about EVAs, extravehicular activities by the US and Russia over time. It has an ID, which country was in charge of it, who were the crew members, what was the vehicle, which is really a mission, what date did it happen, how long did it take, and why were we doing it? So I want this to have, I want to be able to make changes. It's an updatable change, but I want to make sure that no one's tampered with it because we don't want people proving that the moon landing didn't happen because they changed the data. That's my facetious example. So I say I create the table just like normal, and then I have a with clause that says ledger on. I can give it the ledger view a name, but notice I'm not designing it. When this first came out, you got this system name, which was long and terrible and had a lot of numbers. Now you can put a view name on it. You can't change this after you create it. So I recommend you always set a ledger view name. And then to say that it's an updatable ledger table, you put system versioning on, which is the same syntax for using temporal tables. And then you can give it the name of the history table. And just like I said before, you want to do this at the time you create it because you really can't do a lot of alters on these things. So I think this is a recording on the slide, so I'll just talk really quickly. So you can see that when I originally brought in this data, you can see item 1 in the history, they put multiple names in the same column and they had long spaces between them. So I cleaned them up. I should have created another table because it's many. It's a repeating group, but I can't do that now. So I just made it comma delimited in the middle. Yeah, I know. I'm sorry, I can't stop it right now. So I'll just go through this. And so what it's done is when I query the actual ledger table, which is above, it sees the corrected data, but you can see below that it says that the admin changed the data. So originally it was inserted with the spaces, and when I changed it, it deleted the the original value from the table and then inserted the correct value. So kind of like generally accepted accounting principles is how it works. And then the view allows you to look at who did what when. So Kitty Admin or Karen Lopez at a time did this to a change to a table, and did a creation, a drop, an add, or something like that. So this is like, we can log this stuff other ways, but because it's a ledger table, this is data created just for the table. So you don't have to go parse a bunch of logs. So append only tables are just the same, except there's no history table because they're append only. You can't update them. You can't delete from them. You can't modify them. You can only insert. So it's append only. So it has this other stuff. Now, the other thing I should have mentioned before in here, in order for this to work, so that you can use the digest and the log to verify, and we used to say that made tables tamper proof. What we know now is it made it tamper evident. So tamper evident means if someone has managed to mess with the data and they cleaned up their tracks after it, which is usually a hacker or insider risk, now we will see it because the digest, the transactions are immutable. They can't change those. But in order for this to work, you really have to have a separation of duties between the storage account that stores all this and the database. So ledger only tables, just like a datable, but write and read only, and there's no history table, and the ledger view is what we don't need. So I should just let myself speak. So there we go. Sorry. So the reason, so one of the trade-offs here is that you can't alter these tables because that wouldn't make sense. We wouldn't want someone, you can't really alter the table. We wouldn't want someone deleting a column or changing the column like to a shorter data type or something like that. So you do what the rest of the world calls an extended alter. I don't know why the SQL Server community doesn't use this term, but it's when you have to make changes that you can't do online. So you create a new ledger table, you copy with the changes, then you copy your data to the new table and clean up the old table. So that's what you do. So you're altering it, but it's called an extended alter. And that takes time, and you often have to go offline to do that. So now we're going to talk about ledger databases. Oh, there we go. So I'm not sure. There you go.
Can hear you, Karan.
Can you hear the recording? there you go. So you just create this database and you say every table is that way. Yeah. So the ledger digest holds hashes of the values, and like here's where the blockchain comes in. Blockchains chain data together based on the hash of the previous instance to the next one, almost like a little relational database based on a hash of all the data in the row. So you've got these hashes and linked together. And the reason this would reveal tampering is that if someone has changed the data, the hash chains, and now the chain is broken. That's blockchain that should take an hour to explain in one sentence. That they show the state of the data. They're stored outside the database server. So just because someone has changed data in the server, they can't change these digests. You have to have separation of duties to work, and you really should put it on immutable storage and have lots of immutable policies to it. So, oh, there we go. So in this example, so there's not a feature, you actually write this code to ask the system, please go verify my data. And what it does behind the scenes is it goes and checks the data that's in your table, and it says, does it match the digest as it should? So in this case, I messed with the digest because it wasn't in immutable, and I pointed the database to a different digest, and it said, uh-oh, and you write your own message. So I write cute ones. Uh-oh, the ledger cannot be verified. And that could be a problem, right? And it's the other is that you can see the select the try is that it cannot be verified or it can be. It's basically you can only get two answers back. So why do I love this? I can trust my data more that it hasn't been tampered with. This was one of the reasons for blockchain. So blockchain is not cryptocurrency, but it was created at the same time. Blockchain is so that people can trust that the transaction has not been messed with. But unlike full-blown blockchain systems, which are very slow because of how they're designed, this is built into your database, and most blockchain systems are also the data is visible, and therefore you only put data in there like the transaction that happens in crypto coin. What wallet, which in theory can't be tied to a person, but it can, did what transaction for how much money. So that's different than this. You would use these because most people who are putting data in an enterprise database also don't want to make it public. This also keeps you more protected from insider tampering. And one of the things is I use PowerPoint's design feature for smart art, and every time DBA is in something, it always chooses a skeleton. And I choose to leave that because I like that it makes every DBA a skeleton. So I know we're getting close to the end of time, so I just want to point out that in versions of Management Studio 18 or lower, not the current one, not the one that just went GA, it is there's a vulnerability assessment thing that you can do. This was taken out of other future versions of Management Studio, but it would go through and do a bunch of checks on your system, on your server, and point out to you that this is probably a risk. Now, it might be a risk because let's say you do encryption using a third service. And so it's going to say, hey, it's not encrypted or it's not masked, but you might do it another way. So you have to handle these risks and point them. And I'm going to point this out again. You should, if you have Management Studio 18 or lower, and I think SQL Server over 2016, I can't remember, you can run these. And because if you don't, someone who comes in new to your company is going to run this against all the hard work you did and say, look, they're not even managing vulnerabilities. Look at all these vulnerabilities. Now, again, you might be, maybe you choose not to use transparent data encryption because you're using a different encryption, or you don't want double encryption, or whatever the reason you don't do it. That doesn't mean it's a risk. It's a potential risk because you might have covered the risk another way. And then in Azure, this is the best deal in the world, I think, for $15 per, I can't remember if it's server, I think it's server, database server. You can go do all this against your Azure databases or anything that can be reached via Arc-enabled SQL servers for your on-prem stuff, and it will do the same types of things, this vulnerability assessment. Then the last thing I'll point out is that in Azure, Azure itself computes a security score over everything under your tenant or based on a subscription. And like, look at this. My secure score is really terrible, 48%. And it's only aware of stuff I have in Azure. Well, the reason the security score is so low is this is all my test and demo data. So I don't lock down AdventureWorks or Galactic Works, which is my version of AdventureWorks. So yeah, and I also leave things unsecure so I can demo the vulnerability assessment. But I would freak out if, now your score security might be better, but again, if no one has run this security posture and scoring, and again, a consultant's going to come in and tell management it's totally unsecure because you've never run this and you've never managed the score. And the score itself is contentious because, we all debate about whether a practice is a good practice, a bad practice, needed or not needed. But I want to encourage you all to run vulnerability assessments and find out what Azure is saying about your resources. So these are typical things that I see because I don't lock down my databases because they're demos. And then for each risk, it'll tell you, here's how you fix it. And for some certain things, it'll give you the code that will fix it or the instructions on how to do it. So that makes it nice. So the takeaways are, we need to classify our data because we won't know what to secure. We need to put security nearest as possible to data in 2025 because putting in an application code doesn't cover everything. It'll also generally be more performant if we do it inside the database rather than outside because we have to duplicate all that. Data pros know data, developers know code. We all know a little bit about everyone else, but we're experts in these things. And therefore, if data people can help us with these database design features, it frees up DBAs, developers, BI people to worry about things that they're experts in. We can't trust everyone. I say we can't trust anyone, even ourselves, because some of this stuff would even protect us from being stupid and doing stupid things. A lot of these things free up developer productivity because they're not having to build these things in. It helps us manage risk. And I also am a big fan of laziness. So I say the best database designer is a lazy one. And that's my snarky way of saying, let's let the database do all the work. So everything comes down to cost, benefit, and risk. And that's why I've tried to talk about those with these things. So I think I have a thank you slide. So do we have time for questions or no?
We have several questions actually.
So I saw some popping up.
Yeah, they are all in the chat window, but I'm just scrolling.
Yeah. I love when people are active in the chat.
Yeah, Alex is asking actually, could you post a link to some examples of past legislation that have ROI?
So I am working on a blog post for that, where I'm working on a presentation about privacy and compliance legislation and why it's going to require data governance, data security, and data professionals. So I don't have one link for that, but I'm working on it.
Also, he asked, do you have any thoughts about using LinkedIn as a data professional? You are announcing yourself as a target by posting your
Yeah.
position.
Yeah, so that is a trade-off, right? So I mean, I remember my dad was horrified when I first put my name and phone number in the phone book back when we had those, because he believed women shouldn't do that. Um, I think everyone makes a decision based on cost, benefit, and risk about how much they share, how they share it publicly. Like I shared with you my security scores, but then I did say there's no production data in there. There's no real sensitive data. It's just fake sensitive data. So I'm happy to share the names. I mean, normally when if I work in a production system, I'm not allowed to share database names, server names, examples of code we use. And it's not just a copyright thing, it's a security thing. But yeah, I get that. Everyone has a decision about how much they want to share. What I don't do is play all the Facebook games that are used to guess your security questions, like take your birth date, add 5. If it's June, replace it with this and tell me what your Starbucks name would be. So I don't do those because that's just enticing you to give away data that might be used against you.
Awesome. One more question from Mahmoudi. Can Power BI service decrypt the data?
Yeah, so I did answer that during the thing. I'm pretty sure it does because I think I've done a demo on that, but it's all dependent on also if you have the key. So if no one shared you the decryption key, it won't decrypt it.
Awesome. One more question. Are the data also masked at rest? I think Ronan answered this question.
Does it mask what?
So, is the data also masked at rest?
Oh, at rest. So no, it's not. So for dynamic data masking, it's only after the queries, it's only at serving up the data, so the end of the query. Now, Microsoft did write a blog post at one point that they were considering having static data masking and doing that. They didn't pursue it, but I don't know why. But they blogged about that they were looking to do that. And so now if you want to mask persistently, the way I've done that in the past to keep it in the database is use a calculated column. But that also means that I have to make changes to the database if the mask has to be changed. Whereas, I mean, I'm sorry, I have to make the change as well as recalculate all that data. Whereas if you're using data masking, you're not messing with the data. So that's a trade-off for static data masking.
Thank you, Karen. And one more comment from Andreas. At some point, Microsoft realized that calling it security meant legal trouble and tried to revert it, of course. Revert it course.
Oh, I didn't know that. But so the reason I say they call it that is it's listed like in docs in Learn as under the security features. So it's really a categorization thing. But I really don't think, like, I like that people are like it's a security thing in the way that, like, there used to be things like if you left your laptop on a bus, but now we have better ways of protecting it. Or if you printed out a report and didn't go pick it up at the printer, then the data masking helps, but it's not truly security the way I think of database security. So that's just me, like I said, nitpicking on it.
Awesome. So Sweeney, Kevin actually gave an applause saying thanks for this. I have several directions in which to run off and learn more. And
Yeah.
many kudos to you, Karen.
Mm-hmm.
So many applauses here.
Mm-hmm.
I can
Excellent.
say that from the comments that people loved your session.
Well, that's good because I can't see people. That's, as you know, the hard part is you
Yeah,
can't
I
see people.
understand. And Ronan, you would like to speak? Yeah,
No,
maybe.
uh,
Thumbs ups and thank yous and all of that. And thank you so much, Karan, for taking your time and presenting.
Mm-hmm.
at our user group today, and we
Yeah.
recorded the session, so this will
Yep.
be released in the YouTube channel very soon.
Okay.
All the attendees, if you did not follow, subscribe to our YouTube channel, just go ahead and subscribe. It's in the comments, somewhere in the comments. So we usually post all of our recordings over there, week by week. And if you were not able to attend, that will be a good place to go and watch out the recording as many times as you want, right?
And, yeah. And the other thing I wanted to point out is I do share my slides. I use Speaker Deck. When I get these uploaded, I will send you guys, the organizers, a link, and you could put that link in the YouTube if you wanted to,
Yes,
or send it
absolutely.
somehow, and that way
That
people
would be
can see the
awesome.
slides.
Yes, yes, of
Mhm.
course. Thank you so much, Karen, and thank you one and all for joining the session today. And next week, I'm going to present on the same security. I I'll do my level best, but I'm sure I might not catch up
So,
as expert as like Karen Lewis, but
uh,
I'll try.
you did a great job at FabricCon, so it was
Thank
great.
you. Thank you, Karen. And yeah, so see you next week, everyone. And yeah, Ronan will be hosting me for the next session. So thank you, one and all. Thank you, Karen, for being here today. And yeah, have a great day, everyone.
Thank you
Bye.
all. Bye.
Thank you all. Bye.